All right, and now on to chapter 15. Well, really, chapter 14 and 15 are effectively the same chapter. They just split them up for size purposes. But so chapter 15 is effectively commentary on chapter 14. So that's why we're smushing them together. And then so since we talked about the confidence interval portion from chapter 14, I'm going to pull out the pieces from chapter 15 that are relevant to confidence intervals. Okay, so first, when we're talking about margin of error and confidence intervals, it's important to note that the margin of error, when we talk about that, it's only error due to random sampling issues. So because of variation, right? We get X bars that vary wildly in some cases, and so that's just because of the different samples that we selected. Okay, so the margin of error does not cover errors due to poor sampling design, poor experimental design, or just general incompetence on whoever is using these tools. Okay, so those errors still persist. On a different note, when we look at the margin of error itself, there are some interesting relationships. So as alpha increases, what's the behavior of the z critical value? Okay, it's actually the case that as alpha increases, so I'm thinking as alpha goes from 1% to 2% or to 5% to 10%. Okay, what that means is that there's more areas more area left on each of the tails. So actually Z alpha decreases. Okay, and I'm talking about the positive version only. Okay, if you're looking at the positive and negative, it becomes a little problematic. But so as you go to a 10% Z critical value, that should be smaller than the Z critical value for a 5% alpha. Okay. And then if E is small, so if we have a small margin of error, then confidence is small. I'm going to add a little caveat if our sample size is fixed. Okay, we have to be a little careful with that statement, but yeah. So generally, if we have a small margin of error and we have a fixed sample size, then our confidence is going to be pretty small. That confidence level. Okay. Um, Another interesting relationship is that if our sigma is small, right? That's here. That's in direct variation. That means our margin of error is small. Two L's. Okay. And n has inverse variation going on. So it's if n is large, then our margin of error is small, and that's actually the ideal case, is that we have a large sample size to make our margin of error small. So if we see a margin of error that's small, ideally we have a large sample size. Okay? And the last thing that I want to mention is that in some cases, this margin of error that we have, we want something that's very specific, and we can get that. Okay, so if we know what the margin of error is, we can design for that, but we need a particular sample size because the z critical value is fixed, or not fixed, but it's determined based on the sample size, and we also need, and our sigma is going to be fixed as well. Okay, so here's the context. So, yep, we have some temperatures going on, and we remember that our margin of error is, z alpha over 2 times sigma over root n, and how many, that's asking us to find n. Okay, so that means that we must know E, we must know sigma, and we must know the z alpha over 2. Okay, okay, so E here, that's our margin of error, that's our 0.05. Okay, and I just take it as the absolute value version because I would add and subtract that. Sigma is 0.06, oops, 0.6 rather, and then 95% confidence. Okay, so that's where I need to figure out what Z alpha is. And this, again, I can find this by doing norm.inv of 1 minus alpha over 2. Now alpha, since I have a 95% confidence level, that means alpha is 0.05. So 0.05 over 2 comma 0 comma 1. And I get that 1.959964. Okay, so I know all the values, and so let's substitute it in and see what we get. So we get 0.05 E equals 1.9599964 times 0.6 divided by square root of n. Okay, now algebra comes in and I just need to solve for n. Okay, but it may have been a while since we've done this, so first thing I would do is divide by the 1.95, so 0.05 divided by 1.9599964. Okay, I would recommend not punching this in a calculator right away, just so you retain all the digits that you can. And then now, solving for n, I need I cross multiply. You might know how to solve this sort of proportion differently, but I get 0.05 square root n is equal to 0.6 times 1.9599964. Okay, divide by 0.05, square root n, 0.6 times 1.9599964. If the multiplication symbol is here confusing you, remember you can use parentheses. 0.5. Okay, and then lastly, square everything. N is 0.6 times 1.959964 over 0.05 all squared. And I punch this in my calculator to get the following number. 553. Okay, so to get E is 0.05, 553 samples are needed. Boom, done, drop the mic, walk away. But seriously, that's all you have to do. So know that with margin of error, if you need to find the sample size for a particular margin of error, just solve it using algebra, and then also again along the way you might have to do a little bit of Excel work, just that norm.inv.